has begun.
Okay, well, welcome. This is Gaining 2020 Vision during an incident with PowerShell. First off, I'd like to start by thanking our sponsors. As you, of course, know, we couldn't be here if it wasn't for them. So thank you to them. Thanks for all they do. Please stop by their tables and or look into their products. All right, so today I'll be giving you a brief. I'm Fernando Tomlinson. A little bit about myself. Been with the DoD for 18 years. Currently technical director of a cyber operations center. I'm an adjunct cybersecurity professor at a local college down in Augusta, Georgia. I've been dealing with PowerShell for a little bit over 4 years. Really fell in love with it from a blue team perspective. Have developed a number of blue and red team tools, all of which you can find on my GitHub. In the process of getting the PowerShell conference book volume 2 out. I'm a contributor on there. And then there's a couple of ways to kind of connect with me. So if you like to do that, those are the best ways. All right, so here's our agenda. We're going to hit it hard. I think I got like 80 slides. Right. But no worries, they're already out there. All right, so incident response. Why are we talking about this? Well, because something like this, right? There's always failures, and in some cases we see them coming, and it's like, all right, well, brace for impact. But not everything is like that. Sometimes we have an actual plan, and then sometimes that plan doesn't actually work. That really brings us to really why we're here. And as we look at incident response as a whole, and really what it means, right? I kind of got 3 different perspectives, but largely speaking, they're all kind of saying the same thing. Right? In short, we're talking about dealing with an intrusion when something happens in an organization, right? And being able to respond to that and get the business back into a fashion in which it was prior to that incident taking place. So when we look at the different phases, we can always refer to NIST, right? Because that's going to be a good standard. But then there's also a standard in which SANS, if you're familiar with them, cybersecurity training organization, in which they have depicted phases. And really, when we look at these, it doesn't matter to me which one you use, so long as you're using one of them or one of a number of them. But largely, how do they really level out with each other? Well, this is how they do that. You see, obviously, one has 4 phases while the other one has 6. But really, largely speaking, this is where they nest together. Where we're really going to focus, though, is really here on the detection, the identification, containment, the eradication, the meat and potatoes of incident response, if you will. Now, this isn't going to be very linear. We will have gaps with PowerShell. I've already told you I get 80 slides in like 45 minutes, so I'm trying to give you the most I can, and where we don't get to, I'll make sure it's available on my site for you. So these are the common approaches. Go buy a sensor, purchase this device, next gen, right? And that's great if your organization has the budget for it. But let's be honest, sometimes cybersecurity is an afterthought. So we find ourselves doing or trying to do more with the little bit we have. Then there's this thing of, well, just use open source. There's some free open source tools. Well, that's cool. And then you have these network owners that may not fully understand the value that it provides, and therefore doesn't allow you to introduce it to their network. So it's like, you don't want to purchase something for me, yet if I try to utilize something that's already out there, you don't want me to do that either. But if you're so fortunate enough to have either an open source or commercial tool, you'll see that it provides a number of things. Visibility into the network. Who's doing what? When are they doing it? Being able to have some fast response on and in those actions in which people are doing things. Right? You don't want to show up to an incident 7-8 months after an intrusion has already started and then have to explain to somebody why it took so long. Or maybe you do. Maybe you'll then get that commercial tool you asked for. Right? Never let a good crisis go to waste. Right? So if you find yourself without the commercial tool or without the open source tool, your toolbox may look like something like this. And that's okay. Right? I'm here to tell you, you're not the only one in the world. Here's what we're going to do for you today, though, especially on the Windows environment. Linux too, if you can get them to actually install PowerShell, right? We're going to put this in there at least. So you'll have at least one thing, and that's a pretty mighty hammer. I almost feeling like Thor in a sense for power. And then in the end, because PowerShell isn't just one thing particularly, being able to use different aspects of PowerShell, your toolbox may look something like that. And then you may not even be able to tell the difference that you don't have that nice open source tool or that commercial tool. Now, you'll still have shortfalls, right? Like, I don't believe I see a hammer up there, but we see a number of other tools that are definitely great. So no brief is good without a disclaimer, right? Kind of like the lawyers, right? So we have the TLDR, too long, didn't read, but then we also have too small, couldn't read, right? Because that's how legitimately that stuff is. It's like blah, 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 blah. All right, disclaimer's good to go. But here's what we're saying. We're not saying don't go purchase those tools because they're indeed pretty decent, right? The more visibility, the better. What we're saying, or what I'm saying, is if you can't afford it organization-wise, or they won't purchase it for you, that if you're in a Windows environment specifically, there is hope. You already have something available to you that could give you some visibility into the state of your network and could enable you to respond to some incidents. So that brings us into the things that we're going to actually really dive into the meat and potatoes. So each one of the topics in which I talk about, I likely would have a screenshot or two kind of depicting it, and then I got 4 demos that we're going to actually do. All the code that I'm talking about is on my GitHub, so you'll be able to go out there and download and play with it. So in a Windows environment, if I'm running a web server, it may be an IIS server, right? Inherent to a server OS build, I can deploy that as a feature, and then I would be good to go. Now, when I look at the logs that that thing produces, I get something like what's shown below. At the end of the day, that format is going to be an ASCII format that's fixed, that I can't change. If I wanted to open it up because it's a flat text file, I can Control F my way through it, or I can try to ingest it into something, but it's not organized data. So here's what we're going to look to do. We're going to look to change that to an object so I can PowerShell it and actually perform some type of analysis on it. But really, what are we getting? Well, every time somebody goes to a site, they try to access a resource. In this case, somebody is trying to do a GET request on the root of the site, and they're returning, the site, returning a 200, meaning services were good, there's no issues. Now, we may also find that people would try to get services or a URI off our site that doesn't exist. In this case, we see them trying to do the same thing with the root. We see them doing the same thing with /db. Both of those, root returns a 200, meaning the resource is good. But you'll notice db and command.php render a 404. So you have these people all times of the day, likely doing it right now on your own network, that are reaching, hoping maybe they'll find something. So command.php is a web shell. So he's thinking maybe it's already been exploited and maybe he can just access it. For me, this is interesting because I get it. People are going to do this all over the world. But I want to hone in on the people that are doing that. And I want to be cognizant of it and in some form of fashion reduce the threat vector from them being able to do it. Now, based on the data that we're getting out of these logs, it's also helpful for me if I'm managing a server to understand the geographical location. For example, if I'm with an organization that does business solely in the United States or Canada or Mexico, then I may not want to open it up, or I may not want to have traffic from another country in which we don't do business with, right? I want to reduce that threat vector to the best of my ability. So when we look at parsing this log, we have the original aspect that we looked at before, but we're going to take the fields that are already in there. We're going to convert that whole text into an object, and then I just send it to out grid view. So now we see all those properties, i.e. those fields, and then we can utilize it just like we would anything else. Get process or get service and pull those properties and methods that we care about. Now, scrolling down a little bit, we start to see things that we may have missed. In this case, we see a person looking for a PHP admin, thinking maybe our server is written in PHP. No, it's not. Then we see another person who's actually trying to access WP-admin, thinking it's WordPress. No, not WordPress. And then we see where the person's doing command.php, and then there's a command.jsp. Somebody's out there reaching, trying to access what they believe to be a web shell on our server, and that's not the case. Now we're able to parse this with PowerShell. Even further, there are IPs that are likely to hit our server regularly. Like I browse to Google probably on a daily basis. There might be some marketing I just did for them. But there are people who may not go there often. So we're able to stack the URIs, what on our site they looked at, also with the number of times or the number of IPs that tried to access it. So the rate of least occurrence is probably interesting because something like Google.com, people go there all the time. But people trying to go to one-off portions of Google that may not exist cause for concern. So from an incident response perspective, all right, I'm going to stack my list, and then I probably would start with the lowest one. Or if we see something like that command.jsp, that web shell, we would also probably look at who else is accessing it. To get this, we're just using the group object. So we've already conformed it to an object. We're passing it, sending it down the pipeline to group object, and then we're just pulling out the things we care about. We're slicing and dicing this data that was otherwise a flat ASCII text file. So the part about the geolocation, we're able to utilize the API on a free site in which we can submit IPs, and it comes back and it tells us geographically where that IP is located. So now I get to the point where we start to see stuff in maybe random countries. Again, we don't do business there. Maybe we can hone in on why that organization, person, or what have you, that system is accessing our machine. Now, when you find something of interest, let's say an IP address, now you get to the point where you may want to know about the reputation of that IP address. Maybe you find a URL or a domain. Well, if you haven't heard of VirusTotal, that's an asset. VirusTotal has a free API that allows you to query it. It also has a paid-for version as well. The paid-for version, let's be honest, is more towards your organization. No individual is probably going to have a true virus scan subscription because it's rather expensive. Now, although we can also submit binaries, I caution you on that. Because if someone's a malware author and they're checking VirusTotal, if you submit a binary, it will let you know how many times it's been seen. So if a malware is essentially a 0 day, and you find it and submit it, and VirusTotal tells you it's never been seen before, it now increases that counter to say it's been seen once. So you may be informing VirusTotal, who is ultimately getting information from about 50 or so antivirus organizations. So you're feeding them all at the same time. So I advise not the binary, but something like an IP address is all right. Now, with the free API, they limit us. So we have 4 requests per minute, and then we have a number of them that we can do throughout the day. So we get what we get with free. So we end up developing this script that takes in hashes. There's another one that we're talking about today in which we can just query our process list periodically, right, looking for what's actually executing and what's the reputation of that. And based upon these hashes, we submit them to VirusTotal. So as you can see, the first line depicts that we have 2 hashes. The second line renders a count of how many hashes we submitted, and then based upon us only being able to do 4 per minute, I told you, or I'm informing the user that it's going to take 30 seconds because we have to sleep for that period of time. But what we get back is the AV, the version of the antivirus, whether they detected it or not, and if they did detect it, what is the malware family in which they know it as? So looking a little bit deeper, we have this. So you see all the virus AVs, and then all the way out to the side, you see the actual hashes. So looking at this, that one hash, at least 6 antiviruses came back and said, hey, this matches something. And then you start to see in the third column what they know it as. Every AV may be a little different. But if I submit something, a hash, and let's say 20, 25 of the 50 render it bad, that's cause for concern for me. Especially if I understand those AVs. Now there's some AVs out there that maybe would never ever trigger, even if you gave them an underhand pitch. But some of the more reputable ones, that causes for concern. This is a free asset for us. So I'm a firm believer of the event logs. All right, and if you didn't know, 2 different ways to actually parse them. The get event log deprecated, that gets our classic logs. It doesn't get like our event tracing, our technology logs, get when event does. Both of them work remotely. You see some pluses and negatives as far as how they filter and where they do their filter in. Get when event allows us to read them in offline. So you may be in an organization in which you're pounding away at this event, and you're like, I need a little bit of assistance. You can export that log, send it to a friend of yours who can then utilize get when event, read it in, and then maybe run it against some type of parser that they have. Now, when I start to talk about parser, you'll see it in a minute when we start to actually parse an example log. Now, there's no shortage of event logs. Some of them are more informative than other ones. These are some interesting ones to me. Now, if I could only pick one, it would be 4688, and it's not enabled by default, as I see Microsoft stuff here. But I want to know when a process started. Malware, it's going to want to start a process. It's either going to want to start a process or run in the context of another one. But we would want to know when process starts, so we can then hone in and really filter based upon that. So when we look at getting our event log using get when event, and we're able to specify a hash table and the log and 4688, this is what we get by default. We get 5 properties back, or 6 properties rather, and the meat and potatoes is really in the message field. And looking at it like this, it doesn't tell me anything. It gives me a count. That's cool. All right. But then when we look to expand it, i.e. typing it to select object, asterisk, and then I like to do something like first one, attack first one. Give me one, but give me an example of all of that so I can see everything filled out. All right? Like if I'm going to do something with every human in here, I may not do it with all of you at one time. Let me take one of you. All right, you all have 2 hands, 2 ears, 2 feet. Now that I know that, maybe I want your hand and I want your foot. Now I can apply that 30, 40 times in a much seamless place. So as we look at this, the stuff we care about is in the message field. What process started? What command line argument was sent with it? Who started it? That's all in the message field. We can query the message field or filter for that, but if there's a hit, a trigger in the message field, we're going to get it all back because it's just in the message field. As we look at it, it's not clean. So as we realize the message field is what we really care about, in get when event, we have this properties property down at the bottom in which we can expand. And literally everything in the message field is in properties, is a property of properties. So we can expand that, it will be an array, and then we can pull exactly what we want. If you're using get event log, they have the same thing, but it's called replacement strings. So now I'm at the point where we're going to pull those properties, and now for us to be able to see it, zoom it in. But there's certain things we care about. So we care about, like, again, the process that started, who started it, command line argument, the date. Now we're able to parse it just like we wanted. And now those properties are something that we can query upon. Hey, show me all the process creation logs where the property is command.exe or where the property is exe period. And now you get that item back instead of getting the whole message field or trying to do some select string or something else. Much more cleaner. So when a buddy of mine or myself, when we exchange logs, and I get to the point where I'm going to read in 4688, I have a parser. Because the thing about incident response with analysis is it's almost like eating a Reese's. I like to double stack mine. Some people like to poke out the middle. There's a number of ways to do it. What makes you happy? What gets you ultimately to the end point? And analysis is a little bit different in that aspect. So when I was able to do this, now as I look at it, I start to see stuff that stands out. In this case, I see a person using netcat. Now I'm not going to say netcat is bad. Netcat command line tool, typically associated with malicious activity, allows you to either send arbitrary commands, interact with a remote machine through a reverse shell, right? Also has the ability to do certificates, typically not used by an admin, right? So it starts to screen interesting. But when I see that somebody has used netcat and then they're trying to communicate on quad 4s, that's interesting, very interesting. So what started that process? And then you look at what started the process that started it. And then who was logged on around the time in which we identify it was first wrote to this, right? You start marking up your board in a sense where now you start to go deeper to understand. But we may have missed this if we were just looking at get when event, or we looked at the message field, right? Because that was too much for us. We need to chop it up in such a way that it makes sense for us to then go deeper. And you know what? Guess what? Now that we've chopped it up and we have the properties the way that we want them based upon the properties field, we can send it to out grid view. Because again, if you don't have the ability to have something like Splunk or ESM or a security onion or what have you, right? Out grid view is not entirely too bad for analysis. right? Especially very tactical, quick analysis.
Quick question. That NC CAD, or if you renamed it, would it still work?
Yes, but it would show. So the question is, if you rename NC64 to netcat, will it still work? And the answer is yes, but in the 4688 log, it would be whatever you renamed it to. Yep. All right, so this is one of my favorites, right? Because, yeah, got some basketball fans in here, right? It still hurts a little bit. Because nobody knows what JR was doing at the time. I don't think JR knows what he was doing. All right, so typically somebody of malicious nature may get on a system and they're gonna look around. I.e., if somebody was gonna break into your house, they wouldn't necessarily go straight to the bedroom. They would try to pace around and make sure everything is good before they go after what they're there for. Same way if somebody was gonna access your system in a malicious manner. So understanding that, if somebody maliciously got on, looked at event logs, seen you weren't logging 4688, which gives them the sense of assurance that you're not logging process creation, they may get to a point where they start to bring in their tool sets, right? Because they feel like the coast is clear. But we could utilize something like this, do event log, and actually write our own logs for things that we either don't want to use the event log for, or maybe our dev guys built some product in-house, right? And like it's some flat text file. We can then start to log the things that maybe didn't have the ability to be logged before. There's endless possibility. But for me, flat text files for logs, that dog does not hunt. I want to get in the event log because it makes wiping it much harder. If they wipe the event log, it's going to generate an 1102 saying the event log was wiped. Nobody's going to do that, right? So I want to get to the event log, step one. Step two, I want to get it off my system. So we can really follow a methodology like this, where we retrieve the data, we have PowerShell as some type of agent, maybe in some while loop of sorts, and then we filter for the things we care about, i.e., hey, I want to filter for when this process starts containing this hash, or when this user does ABC, and then once we trigger on that, we write it to the event log. The good thing about it is, as you look at it, my event ID is 1337 because I'm your hacksaw and all that good stuff. So you can determine what that event ID is, and you can also determine what that source is. In this case, my source is find notepad. Now, step one I said was to get it in event log. Step two is to get it off the box, right? Get it in the event log, get it off the box. Maliciously, somebody gets on your system. They see you're writing events to the event log. While 1102 will trigger if they wipe it, there are tools and capabilities out there that could enable an adversary or a malicious person to wipe their tracks in the event log. So let's get it off the system, right? Just somewhere else, because now they would have to have access to that other system. That's going to be a little bit tougher unless your organization and construct is a little bit weak. Well, hey, we can't afford Splunk. Or we don't have enough rack room or server space for Security Onion or some other open source tool help. Okay, cool. Well, guess what? Slack seems like a good place for me, right? And they give a free API. Now, I cannot write you cannot write your whole enterprise worth of log system. It ain't gonna happen, right? But now you got to be fine-tuning what you want. What is the one thing you want and you care about? And write those things to Slack. So, looking at it, we can post a message to Slack like this. Now, you see that second line, I have my API in there. I'm like, I probably shouldn't do that. Somebody's going to take pictures of it. Right? So, I'm reading my API in from a file. You can get a free API for whatever your channel and your room is. We have on our third line, we specify whatever our channel is. We have our message on the fourth line, and then we can actually do like an emoji as well. We package that up as an actual hash table, and then we utilize the invoke REST method and post it. All right, should work. Looking at the documentation, YOLO, right? You only live once, so I let it go, and then guess what? It posted. Huh. Well, that's interesting, right? You test, and then you go full blown, like you never go in between, right? So I got to the point where I was like, cool. First off, you can't write the logs if they're not on the disk. I wholeheartedly agree with that. But another methodology, receive the data, filter for the things we want, write the data of interest to the event log, that's step one, monitor event logs for events through our script, and then once those trigger, send them off to Slack. So what does that look like for us? Well, it looks like so. Lots of what we already had in our code, and then here's really the big piece in that last line, right? So this is all in a while statement, so I sleep for a period of time. But now I'm querying the event log, doing some other stuff with the message field so I can get my object straight, creating an actual object, then I'm utilizing the same, nearly same stuff to post it to Slack. Sir?
Another question. Are you speaking from a hacker that wants to move it off the log file
No.
to the DevOps?
Like system administrator or blue team? Yep. Because the event happened, a hacker may try to wipe the log, and now I as a blue teamer come in and the log doesn't exist.
So you're moving all the logs off.
Yep. Absolutely. Right. So that way, even if he does wipe it, I have it in a place which in theory he should not have access to. Yep. Absolutely. Good question. All right. So that's the biggest thing in here. So now I'm able to send stuff. All right, and I start to see stuff already. I see this defend 64, because let's be honest, an adversary will take nearly every and anything and put 32 or 64 on the end of it. Why? Because most humans, sysadmins, when they look at that, they're like, all right, Microsoft, looks legit, and they keep going. All right, so defend 64 looks legit. Now, maybe I'll put it in, maybe somebody would put it in System 32 or something, but outside of that, yeah. And then we start to see some obfuscated PowerShell stuff happen, right? But I've gotten it off of my system, so now even if I got penetrated and somebody tried to clean up, I have it in a place that I'll call pristine. Now, if they compromise my Slack account, that's a different story, right? But I'm doing more with less, and that's what it's about. Sir?
You're only sending the key events that you had.
Yeah, I would recommend against doing the whole thing.
You're just sending just key events.
Yeah.
Communication.
Yeah, and in this case, I'm not getting them as they come. Like I'll get what I care about, and then at a period of time, 5 to 10 minutes, then send them as one message. Because if not, like you said, it's going to be. Yeah. Sir.
Thing is to ensure that the actor doesn't have anything left to be able to post, so they don't get access to your actor because it's doing both in one box.
Yeah. Yeah. So this key it only has the ability to post. Good comment. All right. So if we've already recognized that processes start this 4688, we recognize that's going to give us a lot of good stuff, but also in there we have network connections. And when we look at both of them, they provide great information. When we put them together, because that's already been proven, we're in a much better place. So came up with this verbose process. And what that really allows us to do is it gives us the source, destination IP, and port, the binaries that the process is tied to, that connection is tied to, but also the parent process, and I hash it. So it's very verbose. So we see source information there. We see the actual binary and the parent binary. We see source IP information. We see the source binary. We see the parent binary. This is two different processes. All right, so in one window, without flipping back and forth, I can see a full picture. Because I might see a NetSat connection, but I might see a process, and I might not be able to tie them back together. In one instance, we can see them back together. So we're using PS custom objects here. Get process, get TCP, net TCP connection. PS custom object, put that thing together. All right, so anyone with McAfee products out there, McAfee virus scan, whenever they encounter malware or what they perceive to be malware, they buff it. Essentially, they XOR the binary, put it in C quarantine, and then it becomes an unusable binary at that moment. It sits there for 28 days. Now, from a blue team perspective, great that you stop it, but before I knew about the, undoing it, if you stop the malware and you deleted it essentially, then I don't have a sample to go analyze to better understand what it's doing to feed back in my threat analysis circle, right? So thank you for stopping it, but blue team, I want the binary. I want to analyze it or get it to somebody who can analyze it. So McAfee publishes their key online, and we can take advantage of it and actually undo it. Oh, this isn't conducive.
Change your, put options in, keep it on.
All right, so I'm going to come in here. We'll look at quarantine. All right, so I have a number of these files. When it does it, it randomly names it, but it ends in .dup. So I've assembled or collected a number of them, and then I'm going to run a script and end up writing that actually unbumps them. And what we need to do is feed it the path. So in this case, nope, quarantine. And then it's going to actually take the key, the encryption key, that McAfee or somebody has published online and un-XOR it. So now what I get back is the raw thing. Now, I don't want to put it back in this raw format just to put it back on my system that the antivirus already triggered on, right? So I'm going to zip it, and then I'm going to add a password onto it. So now that we have this, I can go back in here and we'll look at the output. All right, so in this case, we have, looks like Google Drive. We were downloading something. And here, we have this secret script. So let's say I've moved this to my analysis workstation, right? Standalone malware analysis. I'm now going to come in here and we'll look at, actually looking at whatever this is in its raw form. All right, so in that case, it's just our demo script. But I wouldn't have known that. But you can see how we're able to take the thing that McAfee encrypted, tried to safeguard me from, put it back in its original state. Now we, as a blue team, can go conduct analysis on it, make sure it's indeed bad, and then update our sensors and our network accordingly. We don't necessarily want other people telling us things are bad and taking it at face value. So again, if you have McAfee products, that's what that allows us to do. So there's another framework in the building called PowerShell, PowerShell Rapid Response. So enterprise-wide visibility, being able to go out, query a subset of machines, get vital information back that an analyst needs to be able to understand what's going on. Hey, this thing that had happened, is it an event or is it an action incident? Because that's two different things, and sometimes we need to be able to do that. So we're talking about 20 or so items of interest, categories rather, and we're utilizing the pull method. So the issue with the pull method is I can reach out, pull stuff, and then maybe 30 minutes later reach out and pull stuff again. Reach out 30 minutes later or so and pull stuff again, but I may miss what's going on in between them. That's where an agent on the system, or at least the right type of login, comes into play. Now, the output comes back as CSVs, so then maybe we can put it in an out-grid view, or we're lucky enough to have a log aggregation server that we can send it to, but we also put it in a SQL database. Right? Maybe you can develop a front end, or maybe you just like to search data utilizing SQL. So when we look at the categories in which we're able to retrieve data, we see them here. Right? There's a lot of them. So utilizing this, just like so. We'll come in here and I'll run the script. we're presented with a menu. In a domain environment, I can query all systems in the domain controller. I can feed it a text file with systems in there. I can enter systems, or I can pull from our local machine. I'm going to enter a system. And then it goes out and sets jobs. So then it starts to actually go through, conduct this information, conduct this task, receive the information back, and then store it on my actual system, what we're going to call the server. So as it's doing that, we get something like this, where we have a data folder. Our database developed one time and continuously appended to every time we run it. So we see that happening now, where we're at a point on the right-hand side there where it's actually importing the stuff into the database. So we already had them created because we ran it a number of times. Every time we run this, it creates a actual data directory. So we're able to see that based upon the actual time and date. And the items we'll find in there are the CSVs for that group of systems that actually ran. Now, this is full-fledged SQL databases, and as such, I'm just going to use something like SQLite, and then I'm able to read in that information and start conducting analysis. Maybe we'll build a front end using PowerShell so we can have a back-end SQL database in PowerShell, and then also a front end. Now, what we do with this is entirely up to you. Again, as an analyst, we need the information, and we need it in a timely fashion. So that's PowerShell Rapid Response. Again, out there on GitHub. So when we look at the DNS process, when I query for a domain, it's going to check, let's say I'm querying for Google, it's going to check my local host file. And then after that, it's going to check my local cache. And if there's no answer, or it doesn't know where to go, then it's going to go to my DNS server for whatever is configured for my system. If my DNS server has that information cached, it will return it. If it doesn't, it will try to reach out to whoever is authoritative for it. All right, that's the DNS query process as a whole, at large. Now, what we heard in there is a couple of places in which we could utilize DNS to be able to enable us to perform some type of defense, enabling our incident response. And that's really the host file, because again, it reaches to the host file looking for an answer to see if something's in there. So we could utilize the host file, put Google in there, and then put in a fictitious IP address, maybe our loopback. So every time somebody tried to go to Google through the browser, it tries to point back to our own machine, rendering Google not a page that actually comes up. Now, that works from a system-to-system thing, but if we're in an enterprise, that's a lot of work. So what we'll look to do is sync-hold the domain using zone files. Right? So we'll execute the script. It downloads a blacklist based upon malwaredomains.com. So they array a list of blacklisted domains. Now you would want to do your research, right, to make sure those are zone. That for lookup zone then creates an A record. That A record contains quad zeros. So now we just made our DNS server authoritative for all those malware domains. So it doesn't matter which one of them my system tries to go to. I'm going to say, yep, that's me, I got them, and it's quad zeros. My system's never going to go anywhere. Now, it's a different ballgame if the malware author gets to using IP addresses. Right? That's a different ballgame. But largely speaking, we're able to sync-hole a domain. If you're like, sync-hole, yeah, let's take this picture. Somebody's driving, this hole typically isn't there. Now they're driving, the hole is there, they're going to fall in. Sinkhole, right? I'm trying to go to that domain. Now I'm in this hole. I'm not getting there. So importing them in, we'll start to see those domains being listed, and then out to the side, we see the A record where we're becoming authoritative for them. Yeah. Now, if you get to a point where you're like, hey, I want to delete these, where they're all sub-records, sub-zones of one authoritative zone. So if you delete the top-level zone, you delete the malware domains that we created under it. So it's not like you're going to sit there all day trying to delete them. So doing analysis, we may find a process that's malicious. It's going to happen. And in that time, our instinct may be to, let's stop it. No, we need to gain some type of intelligence from it so we can understand what it's doing, its characteristics, and then look forward throughout the rest of our enterprise or our organization. So develop this thing that allows us to do it. And oddly enough, if we attach a debugger to our process, it puts it in a suspended state. So this is awesome. Now, this allows us to look for ransomware keys. It also allows us to not break critical things, right? So malware authors would likely try to jump into a process in which is critical to you that you can't try to terminate. So invoke suspend process allows us to suspend that process. And us suspending it will look something like so. I'm going to have over here where I have a binary, and all it does is he's calling home. He's printing, he's calling home. He's not going anywhere, right? And then what we'll do over here is we'll actually run the invoke process suspend. Actually, first things first, we'll get processed, and then we'll see what the PID is of this demo beacon. All right, so this PID is 7492. Now we'll come in here and we'll run it. We have one parameter of ID. We'll specify 7492, and then it stops. But that process is still running. Now I'm doing some analysis, trying to better understand it. Let's not make a hasty decision of like chopping it off, right? Let's understand this a little bit more. And then maybe we get to a point where it's like, okay, I think we're ready, unpause it. And then I write another function that allows us to resume it. We're going to feed it the same thing, the PID, and then it resumes. There's a third function I won't display here, but it's time. So if you're like, hey, I want to stop this process for a period of time, you can specify a time based upon minutes.
Do you have to have certain permissions to do that?
Yeah, you need to have admin. Yeah, yes,
Do you
sir.
have to have debug or just have?
Yes, you have to have debug. It's like SE privilege debug. I think that it is. Yeah. All right, so from here, that brings us to who's heard of fail to ban? Pretty good program. If I'm on a mixed system, it's great. So what it does is it allows me to set a threshold based upon severity of failed logons and then blocking that IP. So if you have a system that's internet facing, somebody's going to be tagging it every time of the day. You want to deter them by, when they hit that threshold, blocking them from being able to access it. I was looking for a variant on Windows, and while some exist, it doesn't necessarily do everything I needed. So in this case, I actually developed what we needed. So fail to ban would do something like so. The red is somebody trying to log in, just brute forcing, and then we have in green where it was actually successful. So fail to ban, essentially, we're able to set what that threshold is. So after somebody is logged on or attempted to log on within a certain period of time and failed, we then block them. So when we do that, all right, so we have a number of options. All this data is written to a SQL database, so that's good, so we can import it back in. We whitelist ourselves, because that would be bad, all right? Or maybe that would be a feature, depending on who you ask. After that time period in which we depicted to ban the system has passed, it releases it. I'm going to select option 1. Now it's telling me my IPs are going to be whitelisted. Cool. Do I want to whitelist anymore? Now I'm going to say no, and then it presents to me all the IPs on my system. Okay, cool. I'm going to hit enter, and now it's monitoring. So I'll come over to another machine that I have, and I'll try to log on to it 3 times. I think I have it set for 3 times. Actually, we'll do 4 for good luck here. Demo gods. All right, and then after that, it will lock for that period of time, which I think I have set for 15 seconds. And bam, we see that it's kicked in. It's spanning that IP. Now I'll come over here to my firewall, and I see there's a firewall rule. Awesome. On top of that, we'll look at the event logs, because we're going to write that thing to an event log as well. And 1337, we'll do select everything. We'll do it on the first one. All right, so I see that data in the event log. So I have it in the event log, good storage, good keeping. And then I have it in a SQL database, so if I stop the program now or I need to run it again, I have an idea of what is already there and not necessarily starting over. So now I see that that time has passed and that restriction has been lifted. I'll come back into my firewall and I see that rule is gone. So invoke fail to ban gives us a little bit more coverage where we may not have it. You could. Right now I'm running it just as me. So the question is, what am I running it as? And right now I'm running it as me, but you may want to tie it to a service account. You may want to tie the employee. I left that up to them.
That's just one.
Accessing the system, period, in all forms of fashion, all protocols. Yeah. So for all intents and purposes, he or she doesn't even think it's online anymore. Yeah. So with all the great things, and there's still more, there's some downfalls of this. Trusting PowerShell in Windows APIs. If we think a system is compromised, then it's kind of hard to trust something like that. You're taking a chance because a malware author may look to replace either that hosting engine or that DLL, or what else is he doing to the APIs and those calls that we're doing. So there's some consideration there. And then your network may not allow you to utilize PowerShell remotely, specifically talking from the PowerShell rapid response perspective. Lastly, PowerShell may not answer all our needs. It's not 100%. But I tell you what, if I got to go outside and all I have is my night clothes on, if you got a jacket that's like 3 sizes too small, I'm putting it on because it gives me some coverage that's better than what I had to begin with. Now, if you don't agree with that, well, give me that jacket too, then I'll put that one on as well. So here's a couple of other useful frameworks that kind of focus on incident response as well. They all kind of do things differently. Some are somewhat the same, but nonetheless, other assets. So, sorry. Got it? These slides are up. I'm going to give you this link too, so that's what you're really going to want to take a picture of. I say they're up. If they're not, then as soon as I get done, I'll put them up. But so you had a toolkit like this, bare bones, right? And now with a little PowerShell in there, oh yeah. But guess what? I got some more things I want to add for you, right? Because as I give you some tools, inevitably you're giving me some tools, right? Because iron sharpens iron. Well, as we dive into PowerShell, for any language, cheat sheets are great. So here's a cheat sheet that I did about 2 years ago, but it's still very relevant. I teach a 5-day PowerShell course and hand this out. So that's an asset. All right, the other thing is, when we look at PowerShell training, when we look at PowerShell training, it's either not technical enough, focuses too much on programming, not enough on cybersecurity, system administration, what have you. And it may not be interactive with realistic scenario-based stuff. Right, so Under the Wire is something that me and two other people developed roughly 4 years ago. Thus far, we're about 70,000-ish people who have played. You see from, actually I don't even